The game of poker is this partially observable, stochastic, continuous, or adversarial. Please check any or all of those that apply.
The quiz is to determine whether the poker is partially observable, stochastic, continuous, or adversarial.
I would argue poker is partially observable because you can't really see what is in your opponent's hands. It is stochastic because you're being dealt cards that are kind of coming at random. It is not continuous. There's just finitely many cards and finitely many actions you can do, even though you might argue that there's a huge number of different monies you can bet. It's still finite. And it is clearly adversarial. If you ever played poker before, you know how brutal it can be.
The professor selects the poker is partially observable, stochastic, and adversarial.
Let's talk about my favorite, the robotic car. I wish to know whether it is partially observable, stochastic, continuous, or adversarial. That is the problem of driving robotically, say in a city, subject to any of those four categories. Please check any or all that might apply.
The quiz is whether the robotic car is partially observable, stochastic, continuous, or adversarial.
A robotic car clearly deals with a partially observable environment. If you just look at momentary sensor input, you can't even tell how fast other cars are going, so you need to memorize something. It is stochastic because it's inherently unpredictable what's going to happen next with other cars. It is continuous. There's infinitely many ways to set your steering or push your gas pedal or your brake. And, well, you can argue it's adversarial or not, depending on where you live. It might be highly adversarial. Where I live, it isn't.
The robot car is partially observable, stochastic, and continuous.
I want to briefly talk of AI as something else, which is AI is the technique of uncertainty management in computer software. Put differently, AI is the discipline that you apply when you want to know what to do when you don't know what to do. Now, there's many reasons why there might be uncertainty in a computer program. There could be a sensor limit. That is, your sensors are unable to tell me what exactly is the case outside the AI system. There could be adversaries who act in a way that makes it hard for you to understand what is the case. There could be stochastic environments. Every time you roll the dice in a dice game, the stochasticity of the dice will make it impossible for you to be absolutely certain about the situation. There could be laziness. So perhaps you can actually compute what the situation is, but your computer program is just too lazy to do it. And here's my favorite. Ignorance. Plain ignorance. Many people are just ignorant of what's going on. They could know it, but they just don't care. All of these things are cause for uncertainty. AI is the discipline that deals with uncertainty and manages it in decision making.
The first line is AI as uncertainty management. The second line is AI equals what to do when you don't know what to do. The reasons for uncertainty include sensor limits, stochastic environments, adversaries, laziness, and ignorance.